Hello, dear students. Today we are here to speak about nomenclature. Nomenclature is the word that we use in chemistry to explain the rules that we use in order to name a chemical compound. Let's begin by the binary compounds. They are made of two elements. As you can see here, we have one atom of oxygen and two atoms of hydrogen. The way that we use is to write the element that is more to the left in the periodic table first. In this case is hydrogen. And then we write the element that is more to the right at the right. And we use subscripts to indicate the number of atoms of each species. For example, we have two hydrogen, then we write the number two as subscript. In the case of oxygen, there is only one, and we never write the one. This is a binary compound, the one that is made of two elements. Here we have different examples of binary compounds. Here we have the case where we have a metal and a non-metal. In this case, it's very easy. We write first the metal and then the non-metal. But we also have another case where we have two non-metal. In this case, which one is the first element that we write? Oh, we write first the element that is to the left in the periodic table. Then remember that we have two cases, metal plus non-metal and non-metal plus non-metal. But we have what we call ionic compound. What is an ionic compound? An ionic compound is always made of a metal that are to the left in the periodic table, to the left of this zigzag line, and a non-metal that is to the right of the zigzag line that you can see here. But we have two types of ionic compounds. Which one are them? When the metal belongs to um, one of these elements here in group 1, group 2, group 3, 4, 5, or 6, these metals that we call representative uh, made or make, sorry, the type 1 compounds. Then the difference between a type 1 and a type 2 is the kind of metal that is present. Type 2 has to be with metals mainly that belong to this block, the D block, or transition elements, and also some ones that are here that presents two types of different charges. We are going to explain it more in a few minutes. For example, if you have a cation, that is an element that lose electrons and get a positive charge, then this cation that has only one type of charge can make a type 1 ionic compound. For example, hydrogen, lithium, sodium, potassium. As you can see, the name of the cation is the same name of the element in the periodic table. But the second element in a binary compound is always an anion, is negative because they gain electrons. And here we can see that they change the ending by "ide". Hydrogen, hydride. Fluorine, fluoride. Chlorine, chloride. Bromine, bromide, and so on. Then remember, in the binary compounds, we have first a cation, and then second, we have an anion. The cation has the same name of the element in the periodic table, but the anion changes the ending by "ide". Let's see some rules that we use. For example, the cation always has the name of the element, and we write first the cation, and then we write the anion. The cation takes its name from the name of the element, and the anion changes the ending by "ide". Here we have some examples. This is sodium chloride. Chlorides come from chlorine, that which changes the "ide", but the root of the name is the same one of chlorine. Potassium iodide. Iodides come from iodine. Calcium sulfide. Sulfide comes from sulfur. They are type 1 because sodium, potassium, and calcium have only one charge. In this case, sodium is +1, potassium is +1, and calcium is +2 because it's in group 2. But we have the binary compounds type 2. For example, we have iron, that is a transition metal, and chlorine, that is an element from group 7. The metals in these compounds can form more than one type of cation. What does it mean? That they have different charges. We always write the charge of the cation into parentheses using Roman numeral that indicates the charge of the metal cation. Remember that we use Roman numeral in the case of the binary ionic compounds type 2 when they have more than one type of cation. Here we have some examples. You can print this table and use in the exercises and also in the test. For example, iron can be +3 or +2. In the case of iron 3 plus, we write the charge 3 into parentheses using Roman numerals. while iron 2 correspond to iron 2 plus. The older name was ferric and ferrotes for each one, but we use nowadays this nomenclature. I wrote here the older name because sometimes some people used to write or to use this nomenclature, but this is the actual one. Look at this. Tin and lead are not transition metals. They are representative, but as they have two types of charges, we consider them in the type 2 cations. Don't forget this, tin 4 and tin 2, lead 4 and lead 2. Let's see what are the rules naming type 2 ionic compounds. The cation is always named first and the anion second, in the same order that we write them in the formula. For example, first we begin by the cation. In this case, we are in front of iron 3. Then we write iron 3. And the anion is from oxygen, oxide. Then we change the ending by "ite," but we conserve the root of the name oxygen. Remember, first we write the cation and then the anion in the same order that we have in the formula. Well, how can we uh, find out the charge of the element? I'm going to explain you later because sometimes you have only the formula and you don't know what to do with this. Here we have some compounds type 2. For example, copper 1 bromide, iron 2 sulfide, lead 4 oxide. Look at this. All the elements in group 1 will present only one type of charge, that is +1. Then every time you observe that the cation is hydrogen, lithium, sodium, potassium, rubidium, cesium, or francium, you can be sure that the charge of these guys is +1. But if the cation is in group 2, then the charge will be +2. Aluminum and gallium has +3, while the elements, the anions in group 7 will present -3. In group 8, they will have -2. In group 9, sorry, they will have charge -1 in group and here we have the noble gases. The noble gases helium, neon, argon, krypton, xenon, and radon. They have charge 0 because they never gain or almost never. Let me explain about this. There are some cases, but in general, they don't react. They don't gain or lose electrons. We are going to study why they have this behavior later. Well, we have also some cations that are from the transition metals that they have only one type of charge. This is a case of a silver that is always +1, and zinc and cadmium that they are always +2. They are exceptions because in general, transition metals has more than one type of charge. How can we determine the oxidation number, or also known as charge of the ion? For example, I will tell you that we have a compound that is made of aluminum and oxygen. And we know that, look at this, aluminum is +3 and oxygen is -2. Then we write the charges of the cation and the anion. And what we do then? Well, the 2 from oxygen goes as subscript of aluminum, and the 3 plus, only the 3, not the sign, goes as subscript of the oxygen. So the formula will be Al2O3. What is the reason? Well, the charge of aluminum is +3 times 2 is +6. Then the charge of oxygen is 2 negative. But as we have 3 atoms of oxygen, we multiply and we will get -6. If we add +6, that is the total charge of the cations. In this case, we have 2 aluminum per 3 atoms of oxygen. If we add +6 minus 6, we will see that the, the total charge of the compound is 0, because compounds are electrically neuters. Remember that. Well, here we have 2 elements. In this case, we have SnCl2. We have the formula, but we don't know what is the charge of tin in this case. Well, we consider that the charge is X. And as we multiply 2 times -1, we will have here -2. As the compound, the charge, the net charge of a compound is 0, we can find out the charge of tin by doing this calculation. In this case, tin has charge +2, so it will be tin 2. In this case, you say, well, it's X, 4 times -1 is 4 minus 4, as, and the sum or subtraction in this case is 0. We can find out that X, the charge for tin, is +4. Then, in this case, we are in front of tin 4. Rules for naming type 2 binary compounds. The first element in the formula is named first, and the full element name is used. The second element is named as though it were an anion. Then we change the ending by "ide." And the prefixes are used to denote the numbers of atoms present in, and the prefix mono is never used for naming the first element. Well, in this case, we use prefixes. If we have only one atom, we use the prefix mono. Remember, we are in type 2 binary compounds. Well, what are type 2 binary compounds? They are elements that are made of a known metal plus a known metal. Every time we have non-metal plus non-metal, we are in a type 2 binary compounds. Then, as you can see, we name the first element as in the periodic table. Then we use the name of the periodic table. And the second one is considered as an anion. Then we change, we conserve the root of the name in the periodic table, but we change the ending by "ite." And then we use prefixes to indicate the number of atoms in each case. For example, we use mono for only one atom, di for two, three, or tri, sorry, per three, tetra for four, penta for five, hexa for six, hepta for seven, octa for eight. The prefix is the same one that we use in the names of the figures. For example, pentagon, five sides, then we use penta if we have five atoms of the same kind. Let's begin by here. Well, in this case, we have carbon, only one carbon, but in the first element, we never use mono. Then we say only carbon. And we have two oxygen. Oxygen is oxide, but we use the prefix di. Then we say di because they are two oxygen, and we say oxide because the second element is always ended, the name is always ended in "ide." Then carbon dioxide, sulfur, hexa, because they are six, fluoride. Ah, look at here, we have two nitrogen, then we say dinitrogen. And tetra, because we have four oxygen, then tetra oxide. Remember, the second element always ends in "ide." Well, you can follow this flow chart to name binary compounds. You begin by, we have a binary compound. It is a binary compound? Yes, because it has one and two elements. If yes, you say, is a metal present? If there is not a metal, then is a type 3, and we use prefixes to name the compound. If it is a metal present, oh, then if it is a metal present, we have to distinguish if the metal form more than one cation. If no, then you follow this rule and you say we are in front of a type 1 binary compound, and we use the element name for the cation. And the anions always ends in "ite." This is very simple. But here in this case, we have to use prefixes. For example, in this case, we have to use di and the name of the cation, and tri and the name of the anion ending in "ite." Well, Does the metal form more than one cation? Then we follow the same rule as this, except that we have to put into parentheses using Roman numeral the charge of the cation. And then the anion always ending in "ite." Then you can follow this chart in order to name binary compounds. Well, but we have a more complicated case where the ions are polyatomic. What's the meaning of that? Oh, the meaning of that is that we have more than one atom in an ion. For example, NO3 -1, you have more than one atom in the anion. And we know that it's an anion because it's negative. It has a specific name. In this case, it's nitrate. Nitrate. Ending, in this case, in 8. But we also have NO3 -1, that is nitrite. Nitrite. Oh, why the ending changes? We are going to speak about that later. Then polyatomic ions are the ones that are composed of several atoms bound together to make an entity. All right? And have names and must be memorized. In my case, I'm not going to oblige you to memorize. I'm going to give you a table, and you can use this table during the exercises. And we have a special type of oxyanions. The oxyanions always contain oxygen, like in the case of nitrate. Every time you have oxygen, you are in front of an oxyanion. Well, here you can print this table and you can use the in the exams, in mastery, wherever you have to answer a question. Here we have ammonium, NH4 positive 1. NO2 is nitrite, look, and NO3 -1 is nitrate. The difference is the number of oxygen. Less oxygen, we use ite, the ending ite. More oxygen, we use ate. Look, sulfite, sulfate. Hydrogen sulfate, also known as bisulfate. We have in this case OH -1 is hydroxide. Cn -1 is cyanide, phosphate, hydrogen phosphate, dihydrogen phosphate. And here we have one of the most important um, uh, anions, polyatomic anions, or cation in the case of ammonia. For example, ammonia is a cation. It's a polyatomic ion in general, when they are made of more than one type of atom, the cation or the anion. Well, let's see how we name an ionic compound that has a polyatomic ion. Well, we followed similar rules as in the binary compounds. First, we read the one to the left, And in this case, NH4, we come here, we say, oh, NH4 is ammonium. Then we write ammonium first. And then we go to the anion. What, what is this anion? It's very difficult. Then we come here. Oh, it's acetate. Then we call this compound ammonium acetate. Here we have another example. Sodium hydroxide. Then here we have a polyatomic anion. We use hydroxide. Oh, here we have magnesium and nitrate. We have ammonium sulfate. Ah, look at these. This element, iron, can be iron plus 2 or iron plus 3. How can we know the charge? Well, we can do the operation that I showed you before. You write here X because you don't know the charge, or in a simple way, you can say that the subscript of the polyatomic ion is the charge of the cation. In this case, is iron 2. Then you write iron 2 phosphate. Then, what is the overall strategy for naming chemical compounds, binary compounds? No. Ah, then you have a polyatomic ion present. Yes. Then you name using the procedures that we use for binary compounds, but using the name of the polyatomic ion. Oh, you don't have a polyatomic ion. Then these compounds will be named as the in a special way that we haven't studied in this class. Well, you have a binary compound, then you use the strategies that we have seen before. Look, you use this flow chart. Well, let's continue. We have certain compounds that we call acids. What are acids? Well, they are compounds that produce hydrogen ions. And when they are dissolved in water. Acids can be recognized by the hydrogen at the beginning in the formula. The molecule with more than one hydrogen cation attached to an anion. This is the way that you can use to recognize when you are in front of an acid. Look, all of them begin with hydrogen, hydrogen, hydrogen. Well, in the case that is a binary compound, you use the prefix hydro. Then the element here, the anion is chlorine. You use the root chlor, and then always ends in ic. Then you say hydrochloric, and at the end the word acid. That will show that we are in front of an acid. A compound that is in solution will produce cations like this. This is the main characteristic of these acids. Well, in the other case, we have, it's not a binary compound, we have polyatomic ions. Well, in this case, what what we are going to say? Well, if the cation is sulfate, you will change the ending ate by ic. If it is, the ending is, for example, sulfite, then the ending ite changes by O's. Then it will be, sorry, here is an O, O's. Then in this case will be sulfurous, sulfuric, sulfurous acid. Then you use the name, the root of the polyatomic ion, and you changes the 8 by ic and the ite by O's. There is a combination of where ic by 8, O's by ite. For example, oh, here we have binary acids. We know that are acids because of the hydrogen at the beginning. Then we say they are binary. Oh, here is fluorine. Fluorine. Then we use the root fluor. And we begin by the prefix hydro and the ending ic, always. And then we add the word acid. Hydrofluoric acid. Hydrochloric, because it comes from chlorine. Hydrobromic acid. Hydroiodic acid. Hydrocyanic. Hydrosulfuric. Remember, always in binary acids, we begin by hydro. We use the root of the anion, the name of the anion, and we finish adding ic. And also we write the word acid at the end in order to make you understand, or anybody, that we are in front of a compound that produces this kind of protons in water solutions. Okay? Well, in the case of the acids with polyatomic ion, the ending depends on the number of oxygen. You have more oxygen, the endings will be ic. If you have less oxygen, you use the ending O's. And you use the root of the name of the polyatomic ion. That's why here is nitric acid or nitrous acid. Here in this case is sulfuric acid, more oxygen, ic, or sulfurous acid, less oxygen, O's. Well, but there are some complicated ones that have a lot of different combinations with different number of oxygen. Like in this case, well, when you have the chlorine and only one atom of oxygen is hypochlorite. If you have chlorine with two oxygen in the anion, then it is chloride. If it is ClO3 chlorate, and if it is ClO4 negative 1, is perchlorate. As you can see, the charge is always negative 1. What changes? The number of oxygen. According with the number of oxygen, will change the name of the polyatomic ion in the acid. because you will say hypochlorite. In this case, if it is um, an acid, well, in this case, HCl. If it is a salt, a cation, that is a metal, then in this case, you say sodium, for example, sodium hypochlorite, because it's hypochlorite, in this case, the anion. But if it is an acid, then you changes the ite by O's. Then you say hypochlorose. Chlorose, in this case, chloric or perchloric in these cases. Then the ending ate is always changed in an acid by ic. And the ending ite is always changed in an acid by os. Well, here we have some examples. For example, in NO3 is nitrite. In an acid will be nitrous acid. NO2 is, um, in this case, you have the cation hydrogen, then you say nitrous acid because it's an acid. Here you have SO4, negative 2 is sulfate for the cases that you have a metal plus the SO4. But if you have hydrogen at the beginning, it's an acid, then in the case of an acid, you don't say sulfate, you say sulfuric. You change the 8 by ec. Well, that's all for today. I hope that you can stop the video then at any time and try to take notes in order to be sure of how to name a compound, an inorganic compound, because organic chemistry have different rules. Thank you and see you soon.